Welcome to my class 12 Physics, Chapter 2, that is Electrostatic Potential and Capacitance, and topic that is potential due to an electric dipole. That means we will calculate electric potential at any point that may be on the equatorial line, that point may be on the axial line, or may be any point except on the equatorial line or axial line due to electric dipole. Clear? And before discussing this topic, first we will discuss only two mathematical formula or theorem, only two. First one, that is law of cosine for any triangle. Second one, that is the binomial theorem, because in this topic we apply these two mathematical formula. So that first mathematical formula, that is the law of cosine for any triangle. What is the law of cosine? And we applied the law of cosine for triangle here, that is OPB. Look at the diagram. This triangle OPB triangle. OPB triangle. From this triangle, here one angle is there. That angle is equal to theta. Theta is angle between OB side and OP side. We write angle is theta. And one side, that is OP, we write this side is equal to R. Very simple. Another side, that is OB. For this side, we write that is A. Next side, that is BP, we write this side is equal to R1. Clear? And in front of theta, this side is there, that is BP side. BP side, that means we express R1 in terms of R and A. Triangle is OPB, triangle is OPB. We express R1 side in terms of R and A. This is known as the law of cosine. Now, look at the derivation. From triangle BPT, we take another right angle triangle BPT. You know, in case of a right angle triangle, square of BP side, square of BP is equal to BT square plus PT square. That means we write BP square is equal to BT square plus PT square. We write this one. And in place of BP, in place of B to P, we write R1. We write R1. What is BT? Look at the diagram. This distance is BT. So that we write this distance is equal to OT distance minus OB. OT minus OB is equal to this one, that is BT. So that in place of BT, we write OT minus OB. Next, PT square is there, we write simply PT square. And this is A minus B whole square. And you know A minus B whole square, we write R1 square is equal to, that is OT square plus OB square minus 2OT OB. This is A square plus B square minus twice of A into B, that is A minus B whole square. Next, PT square is there, we write that is PT square. And here this is the OT square, this one is PT square. So that what is OT square plus PT square? Again, look at another right angle triangle OPT. OPT. Here OP square is equal to OT square plus PT square. OP square is equal to OT square plus PT square. That means in place of OT square plus PT square, we write OP square. In place of OT square plus PT square, we write OP square. Next, OB square is there, we write same OB square. Minus 2 OT OB, we write minus 2 OT OB. Clear? Then, what is OP? O to P. This side, we write R. So that in place of OP, we write R. What is OB? This one is OB. In place of OB, here A is there. In place of OB, we write A. Next, minus 2, we write minus 2. Here OB is there. In place of OB, we write that is A. Next, what is OT? What is OT? This one is OT. We take the right angle triangle OPT. Right angle triangle OPT. This angle is theta, and you know cos theta. Cos theta is equal to OT divided by OP. OT divided by OP. You know this formula. That implies, what is OT? OT is equal to simply OP multiplied by cos theta. That implies OT is equal to, in place of OP, we write that is R, this one is R multiplied by cos theta. That means in place of OT, we write that is R cos theta. In place of OT, we write that is R cos theta. Clear? And this one is the law of cosine for this triangle OPB. For triangle OPP, this is the law of cosine. That means we express R1 in terms of R and A. We express R1 in terms of R and A. That is R1 square is equal to R square plus A square minus twice AR cos theta. Similarly, look at the figure. Here another triangle is there, second triangle. That is AOP triangle. That is AOP triangle. Here also we applied the law of cosine for this triangle. AOP triangle, one side that is R2, another side that is R, and third side that is A. That means we express R2 in terms of R and A with angle 180 degree minus theta, because this total angle is equal to 180 degree. If this angle is equal to theta, then this angle is automatically 180 degree minus theta. Then in front of this angle, R2 side is there, so that we express R2 in terms of R and A. Here theta is there in the first triangle, but in the second triangle, in place of theta, we write that is 180 degree minus theta, so that in place of theta, we write 180 degree minus theta. And you know cos 180 degree minus theta, that is minus 1, so that in place of cos 180 degree minus theta, we write minus 1. Here 1 minus is there, here also minus is there, minus and minus, we write that is the plus. And this one is the law of cosine for triangle APO triangle. Clear? Then another mathematical formula is there. You also know that is known as the binomial theorem. Actually, this one is the binomial theorem. This one is the binomial theorem. We write here 1 plus x whole to the power n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x square plus this one, and higher order terms are also there. Here we write 2 factorial. What is 2 factorial? 2 factorial is equal to 1 multiplied by 2. What is 3 factorial? That is 1 multiplied by 2 multiplied by 3. What is 4 factorial? We write 1 multiplied by 2 multiplied by 3 multiplied by 4, just like this. Clear? And I applied the binomial theorem just like this. Suppose in place of n, we write that is minus half. In place of x, suppose we write that is twice a cos theta divided by r. So that 1 plus x whole to the power n, we write, look at the 1 is there, plus in place of x, we write twice a cos theta divided by r. In place of n, we write that is minus half. If we solve this one by applying the binomial theorem, the expression is just like this. Here 1 is there, we write 1, then plus nx plus in place of n, we write minus half. In place of x, we write twice a cos theta divided by r. This is the second term. Next third term is there. This one is the third term. In place of n, we write that is minus half. N minus 1 means we write minus half minus 1 divided by 2 factorial, we write 2 factorial multiplied by x square, we write twice a cos theta divided by r whole square. Clear? Suppose we take r is greater than a. This r distance suppose is greater than a, then r square is very greater than a square. If r square is very greater than a square, a square is approximately 0 but not 0. A square is approximately 0. That means here we neglect the higher order terms. So that we write, if we take r is very greater than a, or we write r square is very greater than a square and neglect the higher order terms, then this expression now becomes same thing. 1 plus twice a cos theta by r, 1 plus twice a cos theta by r, power is minus half, we write minus half is equal to 1 is there, we write 1. Next this one. Here 2 cancel. Only remaining is a cos theta divided by r. We write a cos theta divided by r. Here minus sign, we write minus sign. And in this expression, here a is there, so that is a square. Here r is also there, that is r square. That means a square divided by r square. A square divided by r square. And you know a square is approximately 0. So that this term, this is a higher order term, this is approximately or tends to 0. That means we neglect this higher order term. If we neglect the higher order term, only 2 terms are there. Only these 2 terms are there. So that finally we write 1 plus twice a cos theta by r. If power is equal to minus half, this expression becomes 1 minus a cos theta divided by r. That means in place of this, if we applied the binomial theorem, we directly write this one. Clear? Similarly, suppose the expression is just like this. 1 in place of plus, suppose that is minus twice a cos theta divided by r. Power is minus half. Then in place of this, we directly write by applying the binomial theorem, that is 1 plus a cos theta divided by r. Clear? Now, point is, that is the potential due to an electric dipole. That is the main point. That means now we calculate electric potential at any point due to electric dipole by applying law of cosine and binomial theorem. Clear? Now we start the topic. Actually, this is the main point. This is the point number 7. This one is the point number 7 of this chapter. Point number 7, that is potential due to an electric dipole. Now look at the figure. Here electric dipole is there. You know the electric dipole. Di means 2 poles are there. One that is minus q, another that is plus q. Here its magnitude is q. Here also its magnitude is q. That means same magnitude. But this is negative, this one is positive. That means nature is opposite. One is negative, another is positive. That means if we take 2 charges of equal magnitude and opposite nature separated by distance, this is the distance between the 2 poles, that is twice a, then this combination is known as a electric dipole. That means we take one pole, that is minus q at point A, we take another pole plus q at point B, and distance between the 2 poles, that is twice of A. If this distance A to B is equal to twice A, then AO we write that is A. Similarly OB we also write that is A. And this point is the center of the dipole. For center of dipole we write that is O. And from the center of the dipole we draw a line. Suppose this point is a P point, and P point is the observation point. That means at point P we will calculate the magnitude of the potential due to minus q charge and also due to plus q charge, because the 2 charges are there. So that at point P potential due to plus q charge we write V plus. Similarly at point P potential due to minus q charge we write that is the minus V minus. Clear? Then what is the net potential? Net potential is equal to, we applied the principle of superposition. That means V is equal to, V is the net potential, V is equal to V plus V minus. That is the principle of superposition. And from the center of the dipole up to point P, this is the position vector of point P. So that we write that is r vector, because you know always we write position vector is equal to r vector. Similarly here also we know electric dipole moment. An electric dipole moment, that is also vector quantity, and you know direction of electric dipole moment is always from negative to positive charge. So the direction of electric dipole moment is always from negative to positive charge. That means from A to B we write this one, that is the P vector, from A to B. From A to B, that is known as the electric dipole moment, direction of the electric dipole moment. So that we write this is the direction of the P vector, P for electric dipole moment. Clear? And look at the figure. Suppose triangle is OPB triangle. In OPB triangle, this is the angle, means this is the angle between the electric dipole moment and position vector. That means theta is the angle between electric dipole moment and position vector. We write same thing. Let theta is the angle between position vector r vector of the observation point and electric dipole moment. All are there. Then net potential at point P, we write that is V. V is equal to same thing. We write V plus. V plus means at point P potential due to plus Q charge, we write V plus. Then V minus at point P potential due to minus Q charge, we write that is V minus. And you know the expression of the electric potential for a point charge, you know this expression, V is equal to 1 divided by 4 pi epsilon 0. If charge is positive, we write plus Q. If distance is r, we write divided by r. You know this expression. Similarly, if charge is negative, we write V is equal to 1 divided by 4 pi epsilon 0 minus Q divided by r. You know this expression of the electric potential. Clear? Here also I apply same thing. V plus means at point P potential due to plus Q charge. This is the distance. This is the distance between the charge and the observation point. We write that distance is equal to r1. So that we write in place of V1, 1 divided by 4 pi epsilon 0, charge is plus Q divided by distance. Distance is BP. We applied this formula. Similarly, V minus, in place of V minus, we write 1 divided by 4 pi epsilon 0, charge is minus Q, and distance between minus Q charge and the observation point is equal to this one. We write this distance is equal to R2. So that we write in place of R2, we write FP, because this point is A, this point is P, that is FP. So that we write in place of BP, we write here this one. In place of BP, we write R1. In place of FP, we write R2. In place of BP, BP means this one. In place of BP, we write R1. In place of FP, we write R2. Clear? And look at the derivation. Here 1 by R 4 pi epsilon 0 is there. Here also 1 divided by 4 pi epsilon 0 is there. We take 1 divided by 4 pi epsilon 0 as a common. Here also Q is there. Here also Q is there. So that we also take Q as a common. That means if we take Q divided by 4 pi epsilon 0 as common, then remaining is equal to here only 1 divided by BP, here minus 1 divided by FP is there. So that we write just like this. And in place of BP, we write R1. In place of FP, we write R2. Suppose this one is the equation 1. That means V is equal to Q divided by 4 pi epsilon 0 multiplied by 1 by R1 minus 1 by R2. Now, first we calculate what is 1 by R1. Next, we will calculate what is 1 by R2. Then you directly put the values of 1 by R1 and 1 by R2 in equation 1 and we get the final expression. Clear? So that first we calculate what is 1 by R1. This one. Here we applied both the mathematical formula. One is your law of cosine and another is your binomial theorem. By applying law of cosine and binomial theorem, finally we get just like this. That means we write this one is the law of cosine. Look at the diagram again, once again. R1 square is equal to R square plus S square minus 2AR cos theta. R1 square is equal to R square plus S square minus 2AR cos theta. R1 square is equal to R square plus S square minus 2AR cos theta. Clear? This is the law of cosine. And here we write R1 square is equal to, first term is R square. We take R square as common. If we take R square as a common, here only 1 is there. This is A square. We write A square is just like this. We write A square is equal to A square multiplied by R square divided by R square. if we take r square as a common, only remaining is equal to a square by r square. So that only remaining is equal to a square by r square. Clear? Similarly, here 2ar cos theta is there. Twice of ar cos theta. We write this is equal to twice ar cos theta multiplied by r square divided by r square. Same thing. If we take r square as a common, remaining is equal to twice ar cos theta divided by r square. 1 r cancel. This is equal to twice a cos theta divided by r. So that we write twice a cos theta divided by r. Clear? Then r1 square, we write r1 square is equal to here this is a square by r square. If r is very greater than a, then what happen? We write r square is very greater than a square. Then in place of a square, we write that is approximately 0 but not 0. A square is approximately 0 or tends to 0. So that we neglect a square by r square. That means in place of this, simply we write tends to 0. The final expression is equal to r1 square, r square. If in place of this we put 0, remaining is equal to only 1 minus this one. This one means twice a cos theta divided by r. Clear? Then here r1 square is there. If we divide just like this, 1 by r1 square is equal to, look at this expression. This is r square into 1 minus twice a cos theta by r. So that we write this is 1 divided by, here r square is there. We write that is r square multiplied by 1 minus twice a cos theta divided by r. This is equal to, we write just like this, 1 by r square multiplied by 1 divided by 1 minus twice a cos theta divided by r. We write just like this. That means we write 1 divided by r square. In place of this, we also write 1 minus this one, twice a cos theta divided by r, power is equal to minus 1, because 1 divided by this one is equal to 1 minus twice a cos theta by r to the power minus 1, both are same. So that look at the expression. In place of this, we write just like this. Clear? Then here 1 by r1 square is there. If we take root over in both the side, then root over of 1 by r1 square is equal to 1 by r1. If we also take root over in the right hand side, in place of 1 by r square, we write 1 by r. And root over of this one, root over means minus 1 multiplied by half. So that minus 1 multiplied by half means we write that is minus of half. This is the expression. And we applied the binomial theorem directly. This one is the binomial theorem. That means in place of 1 minus twice a cos theta by r whole to the power minus half, we write this one is same as 1 plus a cos theta divided by r. So that we directly write in place of 1 minus twice a cos theta by r, in place of this one power is minus half, we directly write that is 1 plus a cos theta divided by r. Clear? That means 1 by r1 is equal to 1 by r whole multiplied by 1 plus a cos theta divided by r. Similarly, what is 1 by r2? Now, here we calculate same process, same thing, that is 1 by r2. Same process. We applied the law of cosine. We also applied the binomial theorem. If we applied the law of cosine, this is the law of cosine. R2 square is equal to this one. You know this. This one, r2 square is equal to r square plus a square plus twice a r cos theta. So that in place of r2 square, we directly write, by applying the law of cosine, r square plus a square plus twice AR cos theta. Clear? Same process, same thing. We write R2 square. We take here R square as a common. If we take R square as a common, first term remaining is equal to 1. From A square, if we take R square as a common, remaining is equal to A square divided by R square, just like before. From this term 2AR cos theta, if we take R square as a common, remaining is equal to this one, twice A cos theta divided by R. We write R square, R2 square is equal to R square, 1 is there, we write 1, this is A square divided by R square. If we take R square is very greater than A square, then A square is tends to 0, so that in place of A square by R square, we put that is approximately 0, so that only remaining is equal to twice A cos theta by R, we write twice A cos theta by R. Then we divide just like this, in place of R2 square, we write 1 by R2 square, and in place of this one, we write 1 divided by R1 square multiplied by 1 plus twice A cos theta divided by R. This is 1 by R square, and in place of 1 divided by 1 plus 2A cos theta by R, we also write that is 1 plus 2A cos theta by R, power is minus half, just like this. Suppose 1 by R, we write that is R to the power minus 1, clear? Then we take root over in both the side, so that 1 divided by R2 square and the root over of this, we also take root over in right hand side. Root over means power is equal to half, so that in place of R2 square and its root over, simply we write 1 by R2. Here 1 by R square, its root over, we write 1 by R. Here this is 1 plus twice A cos theta by R, its root over means here multiplied by half means we write that is minus half. And we directly applied the binomial theorem, so that in place of this, by applying the binomial theorem, we write 1 by R2 is equal to 1 by R. In place of this, we write that is 1 minus A cos theta divided by R. Clear? So that now, look at the equation 1. This is the equation 1. Potential V at the observation point, that means at point P, is equal to Q divided by 4 pi epsilon 0, 1 by R1 minus 1 by R2. First, in place of 1 by R1, we put the value of the 1 by R1. Next, in place of 1 by R2, we put the value of the 1 by R2, so that the equation 1 becomes just like this. V is equal to Q divided by 4 pi epsilon 0, in place of first one. Again look at the equation. In place of the 1 by R1, we write here that is 1 by R multiplied by 1 plus A cos theta divided by R. And in place of 1 by R2, we write this one. Clear? Then this is Q divided by 4 pi epsilon 0, we write Q by 4 pi epsilon 0. This is 1 by R multiplied by 1, we write 1 by R. 1 by R multiplied by A cos theta by R, so that we write A cos theta divided by R square, we write A cos theta divided by R square. Minus sign is there, This is 1 by R multiplied by 1, we write 1 by R. Minus sign is there, that is minus sign. Next, 1 by R multiplied by A cos theta divided by R, so that is A cos theta divided by R into R, that is R square. If we open the bracket, then this minus sign now becomes plus, this one. Then here, this one is your 1 by R, this one is your minus 1 by R, both are cancelled with each other. Only remaining is A cos theta by R square, this is also A cos theta by R square, that means twice of A cos theta divided by R square multiplied by Q divided by 4 pi epsilon 0. Then here 2A is there, this is the distance between the two poles. Distance between the two poles is twice of A, you know that. And here Q is there, that is the magnitude of the any pole, because magnitude of the minus Q charge, that is Q. Magnitude of the plus Q charge, that is also Q. And you know, distance between the two poles multiplied by magnitude of any pole, that means 2A multiplied by Q. 2A multiplied by Q, that is the dipole moment. That means in place of twice A Q, we write the dipole moment, that is P. So that finally we write in place of twice a q, we write the dipole moment, that is p. Cos theta is there, we write cos theta divided by 4 pi epsilon 0 r square. Clear? So that finally we get the potential at the observation point, that means at point P, that is V is equal to P cos theta divided by 4 pi epsilon 0 divided by r square. This one is the final expression. This one is the final expression of the electric potential at the observation point due to electric dipole. Clear? Now we also write same thing here, P cos theta is there. P cos theta. You know P means electric dipole moment, and electric dipole moment is a vector quantity. You know that. We express P cos theta just like this: P vector dot r vector. P vector dot r cap. This is r cap. How? Look at this expression. You also know before vector A dot vector B is equal to a B cos theta. That is the dot product. You know that. We apply same formula. This is equal to, this is P vector in A vector dot B vector is equal to a B cos theta. We write same thing. P vector dot r cap is equal to P second vector, that is B vector, its magnitude is equal to B. Vector is B, its magnitude is equal to B. Here vector is r cap, that is a unit vector, its magnitude is equal to 1. So that we write 1. Multiplied by cos theta, theta is the angle between a vector and a B vector. Here also multiplied by cos theta. Here also multiplied by the cos theta. That is, finally we write P vector dot r vector is equal to P multiplied by 1 into cos theta, or we write that is P cos theta. That means in place of P cos theta, we write P vector dot r vector. In place of P cos theta, we write that is P vector dot r vector. That means finally we express the electric potential at the observation point is equal to V, that is equal to P cos theta divided by 4 pi epsilon 0 r square. We also write just like this: V is equal to 1 divided by 4 pi epsilon 0 P vector dot r cap divided by r square. Clear? Now two special cases are there. What are these? Now I calculate the electric potential on the axial line and on the equatorial line by applying this formula. Now look at the figure diagram. This point is the center. This point is the center of the dipole. Suppose this one is your equatorial line. For equatorial line, what is the angle theta? This angle is theta. In place of theta, we write 90 degree. That means for equatorial line, angle is equal to 90 degree. Clear? This one is your axial line. This one is your axial line. For axial line, what is the angle? This theta now becomes 0. For axial line, theta is equal to 0. For equatorial line, theta is equal to 90 degree. Only we put this one. First, on the dipole axis means on the axial line. On the axial line, we put theta is equal to 0 or theta is also pi. If theta is equal to 0, you know cos 0 is equal to 1. So that in place of cos 0, simply we put 1. If theta is equal to pi, in place of theta, we put pi, cos pi is equal to minus 1. So that finally we write V is equal to plus or minus 1 divided by 4 pi epsilon 0 P divided by r square. This is the expression of the electric potential on the axial line. Similarly, on the equatorial line or equatorial plane, you know theta is equal to 90 degree. So that in place of theta, you put 90, cos 90 is equal to 0. So that 0 by something, that is equal to 0. That means on the equatorial line, electric potential is equal to 0. Clear? So that finally write electric potential at any point on the equatorial plane is 0. And this is all about your electric potential at any point due to electric dipole. Clear? And in the next class, we will discuss about another point, that is potential due to a system of charges. That means we take n number of charges. Suppose this point is observation point, and at this point we calculate the magnitude of the electric potential due to the n number of charges. Thank you.